Good morning, students. The topic for today is N-gram language models from Module 1. So already we know the concept of N-gram language model. It may be 1 gram, 2 gram, which means bigram or trigram. It leads to N-gram language model. So unigram, we are just taking a separate word, a single word, and checking whether it is meaningful, whether the spelling is correct or not. Bigram means we are combining two words together and checking whether the grammar is correct or meaningful. So this is about n-gram. So how we are applying this n-gram language model in this NLP? So the main application of this NLP N-gram language model is the next word prediction or the future word prediction. Okay, normally in a Google search, you well know about this. When you are started typing one letter, it shows you lot of suggestions, right? Which means it is automatically predicting the upcoming word or future word based on the history, whatever you are searching previously, or based on the priority of words all over the world, what the in their users are searching. Okay, based on the priority of the word, the next words or next letters are suggested to us. Okay, so the next word prediction is the major application of NLP. So in this future prediction, we are using this n-gram language models, as well as we can count how many times the particular word is occurred in the corpus, a very big corpus or a very big number of collections of words. Okay, for counting as well as the prediction of future words, we can use this n-gram language model. Okay, so the example given here is Alex swallowed a large green dash. Okay, so as human being, we know from this four option, these four things are in green color, but what item can be swallowed? It must be a pill. Okay, as a human, our brain have the capability to find the correct answer. Okay, but what the system will fix as a correct answer. Okay, how the system know, how a machine know the pill would be the correct answer. Okay, this can be done by this n-gram language model. Okay, so this next word prediction can be done by three kinds of knowledges. That was either a domain knowledge, syntactic knowledge, and lexical knowledge. Okay, domain knowledge, we all know, the example here is the fisherman went to the bank. Okay, so by default we are thinking he went to the river to get the fishes. Or if we are using this bank word, in for me it may be thinking about I went to the bank to collect the money, or whatever relevant to it, it's relevant to the bank. Okay, so it is called as domain knowledge. Then second one is syntactic knowledge. So we all know syntactic means meaning. Okay, the example is the chicken is ready to eat. So when we are hearing this statement, we have the assumption of it may be chicken 65, grilled chicken, whatever it is. Okay, we won't think about the fresh chicken, right? It must be a cooked one. So this is called a syntactic knowledge. Then lexical knowledge means the knowledge about the particular word, only a word. Okay, I saw her duck. It means, see here in this picture, if this sentence is used at the time of some whatever we can say, in a football or a volleyball, the duck may be mean to this one. Okay, if a girl goes with some duck, it is comes under this meaning. Okay, this is called as lexical knowledge. Based upon the meaning of the word, we are thinking what it may be based on the situation in which background that particular word is used. Okay, so three kinds of knowledges are used to suggest the future word or predict the future word. Then here context sensitive spelling correction. Okay, same thing, in which context we are using the particular word. Okay, in this kind of story book, what might be the word, that is the suggestion the system or model is giving or suggesting to us. Okay, the office is about 15 minutes from my house. Okay, so when I am telling this particular statement to Google Voice Assistant, it automatically recognizes it as minutes. Okay, so see here, P represents the probability. Okay, so two kinds of spelling are here for the minutes. Okay, about 15 minutes from, then same thing, minuets. Okay, two set of spelling. Okay, so in a dictionary, this word is also there. This is also a meaningful word. Okay, but how the system will know, by default, this spelling minutes will comes in the particular statement. Okay, so which one is having higher probability? This one, minutes. Okay, so how the system is calculating the probability to suggest the future word or the next upcoming word? This is called as context sensitive spelling correction. Okay, based on the number of occurrence as well as the based on the story or a particular situation, what the word will be, what is the probability of occurring of words. Okay, then similar kind of example which is given for speech recognition. When we are using Google Voice Assistants, someone is spelling this sentence, I saw a van. Okay, so this may also be considered or found by the Google Voice Assistant as eyes of an. Okay, but which one is having higher probability? I saw a van. Okay, so the system by default or automatically type the sentence I saw a van. Okay, so this is how the probability as well as the upcoming suggestion should be given for the user. So this is called as context sensitive spelling correction. Okay. So here we are using this Ngram language model. Possibility of assigning a probability score to the next word in a sentence. So for a sentence or for a word, we are assigning a particular probability for each and every word. Okay. For instance, I am typing how in a Google search. Okay. So the suggestions may be how are you? How do you do? How old are you? Okay. But which one is having higher priority or higher probability? How are you? Okay, this not only in a Google search, when you are typing messages to your friend in WhatsApp, the same kind of suggestions we also getting. Okay, when we are typing a, my name would be come in my WhatsApp chat, because frequently I type my name to send some contents. Okay, so if I'm typing B, it automatically suggests Bhamini as the first probability. Okay, so like this, which one is getting the highest probability of occurring as a next word in a sentence. Okay, so this is called as language model. So this can be used in the spelling correction, speech recognition, grammatical error correction, machine translation. Okay, a lot of applications this language model we can be used. So this n-gram language can be applied for unigram, bigram as well as trigram, but in this chapter we are only practically trying the bigram language model by combining two words for predicting the sequence of next words. Okay, so how we are predicting the next word? By reading or checking the sequence of previous word. Okay, so here in a set of words, the previous words can be named as n minus 1. Okay, using the previous n minus words in the sequence, we want to predict the next word. Okay, consider this five words similar to human word prediction. Okay, so I want to know, similar to how human word, what would be the next word. Okay, so I want to predict what would be the word here. Okay, so at that time, these four words are called as n minus one previous word. for predicting the word N. Okay, is it clear? For predicting the upcoming next word N, I want to check the previous N minus one word. Based upon the previous words, we can able to predict the next upcoming N word. Okay, this is how we are writing this Ngram language model as an equation. Okay, so the Ngram subsequence can be termed as N items from a sequence. So as you know already, unigram means it's an n-gram of size 1, bigram size of 2, trigram means 3. So this n-gram can be applied based upon the phoneme, syllables, letter, word, and etc. Then a little example given here. The dog smelled like a skunk. So as for a bigram, we are combining two words. You keep one thing in your mind when we are solving the problem for bigram. If this is a sentence given to you, at first you have to consider there must be a start word. There must be a start word here. Okay, sorry. Here. I can't able to point the pointer. Okay, nearer to, in front of this p. Okay, in front of this the word, we have to assume there must be a start word as well as the end word. That's why here hash is represented, but while you are solving the problem, you will use the words like this. Yes. Okay, start word can be represented as yes, and the end word can be represented as here. Okay, start and end tag, like in HTML normally you use the tags. Okay, in the same thing, if a sentence is given to you, assume there is a start tag at the starting of the statement and end tag. Okay, so in this manner the bigram can be splitted for a given sentence. Okay, so how to predict the next word? So assume that in a language T word types in a lexicon, how likely is word X to follow word Y? Okay, which shows that the likelihood of X occurring in new text based on its general frequency of occurrence estimated from the corpus. Okay, so example is popcorn is more likely to occur than unicorn. So this is the textbook taken as the example for calculating the unigram. Okay, what they are suggesting here, popcorn is the more likely to occur than unicorn. Okay, what was the book title? Unicorn who likes popcorn. But which word is occurring frequently, lot many times? Popcorn. Okay, so there is a frequency calculation. So based upon this frequency only, we can able to predict the words. Okay, number of occurrences. So the word Y can be calculated based upon the occurrence of the previous word X. Okay, this is the way we can able to move to the next content. Okay, now we are coming to make this concept into a mathematical manner, in an equation manner. So what is our goal? Compute the probability. Compute the probability. That was important. In the problem also, we are calculating the probability of a sentence of or sequence of words. Okay, so compute the probability of a sentence or sequence of words. So how we are writing the probability? P of this you already learned in your maths classes in your school days itself. Probability of particular word. Okay, so how we are calculating the probability of it, which is based upon the number of words already occurring. So these words are called as W1, W2, W3 up to Wn. Okay, so our goal is compute the probability of the sentence or a sequence of words. So for that, what task we are doing, that is called as related task. Okay, so probability of an upcoming word, that can be represented by the equation probability of W5 in W1, W2, W3, W4, which means that I'm calculating the probability of word 5 based on the number of words 1, 2, 3, and 4. Okay, so this is how we are writing the equation. Okay, so a model is generated based on this thing. A model that computes either of this is called as language model. Okay, by default, you can take this equation P of W equal to this one. Okay, P of Wn, which is based upon W1 to Wn minus 1. Okay, then similar kind of concept only in this slide also. The n-gram language model predict the probability of a given n-gram within the sequence of word in a language. Okay, so what would be the likelihood of the next letter? So this can be occurred based on training data. Okay, so n-gram, how to calculate the probability of W? So previous n minus 1 words, previous n minus 1 in a sequence of history to predict the next word. So this can be computed as probability of W in a history. Okay, probability of occurring word W in a history. History is represented as such here. In the previous slide, what we learned, probability of W5, or it may be Wn, which is based upon W1 to Wn minus 1. So this equation can be given as a statement here. Probability of the its water is so transparent that. Okay, so already we know the particular statement or a sentence. Its water is so transparent. This is the statement. Okay, I want to calculate the next word, this word. I don't know this word, what will be occur here. So how I am calculating probability of that, till that I know. Okay, so the next word would be that, but I don't know which one will come here. So I want to know the probability of the based on the previous words. So you have to write the next word at the first, then one line here. After that, the previous all words. Its water is so transparent that. Okay, this is how we will calculate in the problem also. Okay, this is the way to write the sentence in the equation manner. Always you keep this in your mind, probability of the upcoming word, then only you have to write the previous word. Okay, you have to write it in a reverse manner. Next word, then the previous word. Okay, so in equation we can write like this: probability of this, its water is so transparent, equal to, here P represents probability and C represents the count. Okay, count of the number of words, which how does the frequency of words that would be counted. Okay, that's why here C is represented. So the probability is calculated by calculating the count of its water is so transparent that the how many times the word is occurring with the, divided by how many times the word is occurring without the. This is how the count is calculated to get the probability of the in a given statement. So when we are solving the problem, you can easily understand. So every probability of word can be found, and everything would be multiplied to get the final probability. Okay, so we can use chain rule also here. Similar formula would be, we can write it in a chain rule. That's why it is written like this. So the intuition of n-gram language model as well as Markov chain model. This is the equation representation for the probability of next word in Markov chain. Okay. So finally, we'll come to the problem. Okay, so this all the statements given to you. These are the statements. So already I said to you, if a statement is given to you, please assign the start tag as well as end tag for every sentence, not for a word. For every sentence, assign the start and end tag if it is not given. If it is already there, keep it as it is. Okay, so just I am calculating the probability of I here. Okay, I want to calculate the probability of I, how many times it occurring as a start string. Okay, so for this, I have to write it like this. Probability of I is occurring in front of after the starting string. So how many times you will calculate the probability? First, for the check how many times the starting string is occurring in a given all statement. So how many times the starting string is occurring? Totally 3 times. So the count is 3. Okay, then now you check how many times that I is occurring after s. I is occurring after x. Yes, that would be the answer here. So after yes, how many times I is occurring as a start string? 1, 2. So the answer would be 2. So the probability of occurring I as starting string is 2 by 3. So the answer would be 0.67. Okay. Consider the word am. Okay, I have to check how many times am is occurring after I. What is the probability of occurring am after I? So how can I write probability of occurring am after I? So probability of occurring am after I. Okay, so how will you calculate the probability? Count the number of times I is occurred in a given all sentence. 1, 2, 3. Okay. So denominator it is 3. How many times I am is occurred? I am. I continued with am. 1, 2. Okay, 2 times. So here also the answer is 2 by 3. This is the probability. Okay, so the second letter you write it in the denominator. Okay, second word you calculate the count, number of count, and write it in the denominator. And second word it continued with the previous word that is, comes in the numerator. This is how we are calculating the probability. We'll move to the another problem. So two kinds sets of problem can be asked in this bigram model. One set of problem is maybe this kind of statements would be given to you. I want to eat Chinese food, whatever statement. Okay, from that you have to calculate the probability of next word. Sometimes the probability of this word should be given to you like this table. Probability would be there. So the only thing is you have to know how to write the equation. Okay, how to write the probability statements. Okay, if you know how to write the probability statement, you can easily get the value from this table and you can calculate and find the final answer. Okay, we'll consider this example. Probability of I want to eat British word. How does the probability of occurring these words continuously? Okay, so each word by word I am taking to solve this. Okay, how will you calculate? At first, I already said to you, consider a starting string is there. Okay, starting string as well as the ending string. Okay, so by default the first probability is probability of I in a starting string. Then next sentence is, what is the next word? Probability of want. So probability of want in a. Then only we can calculate I want. Okay. The next one. Probability of 2. Okay. So probability of 2 in a want. Okay. Next is probability of eat in 2. Okay, this is how we move on. Then find the answer for this. Where are the probability of this? It may be in the previous one. Okay, it's not given here. To eat. To eat. What is the probability of to eat? 0.26. 0.26. Check the probability of want to. Want to is here 0.65. 0.65. Okay, this is how we are calculating and multiplying. Finally, we are getting the entire probability for the statement I want to eat British food. Okay, so this is one kind of problem in bigram model. Just sentence would be given to you, so that you have to assign a start and end string or end tag. Split every word with the previous occurrence of word. The probability would be given in the question. Just you take the probability and substitute, multiply, you will get the answer. Okay. So the second kind of problem would be, this is how. Okay, a set of corpus would be given to you, set of statements. Okay, from this, they have been asked to calculate the probability of any other new sentence. Okay, so here the test sentence is Amar is reading a book. Okay, but there is no sentence here, Amar is reading a book in a training corpus. Okay, so how we are calculating the probability of this sentence, Amar is reading a book. Okay, so this is the problem, but we have the test sentences. Amar is reading a book. This is our test sentence. Okay, so put a start and end string. Okay, so what would be the first probability? Probability of Amar in a given starting string. This is the first probability. So how will you calculate? Second would be comes in the denominator. So check how many times the starting string is occurred in a given training corpus. How many times starting string is occurred? 1, 2, 3, 4. Okay. So 4 is the answer. Then how many times yes is coming with Amar? Okay. Yes with Amar. That would be written here. Check. Starting string with Amar is coming only one time. 1 by 4. This one. Okay. So the answer is 0.25. Okay. So this is how you have to write the probability statement for each and every word one by one. First word we written. Okay. Then the second word, probability of is in a given Amar. Okay, so check how many times Amar is occurring in a given sentence. One, then two, then where it is only two Amar is there. So two. How many times Amar is occurring? Amar is only Amar is here. Only one statement is there in Amar is 1 by 2. Okay, then next probability. Probability of Amar is we calculated. Next word is reading. Okay. Reading is. Reading is. Next is probability of a reading. Next, probability of book a. Next probability. Probability of end string upcoming with the book. Okay, so check one by one for every words. You'll get the probability from the training corpus. From the training corpus, you are calculating the probability for the text corpus. Okay, take the third word. How many times is occurring? 3 times. Okay, how many times is reading is occur? Is reading. Our reading is here. Is reading 3 times. 1, 2, 3. Okay, so 3 by 3. Then how many times reading is occur? 1, 2, 3, 4. 4 times. 4 times. Then in the numerator, check how many times reading a is occur. Reading a. 2 times. Reading a. Reading a. Okay, so this is how we are calculating the probability. Finally, you are multiplying all to get the final probability. So the probability of occurring Amar is reading a book is 0.056516. Okay, this is the way to find the next words. This is how the next word suggestions is given to you in Google as well as WhatsApp messages, normal text messages. The all next word suggestions are based on this kind of Ngram language model. Okay, so this problem we applied only for the bigram language model because we are considering only two continuous words. If you want to do this for a trigram model, you have to take three words. Okay, I think you got the point and understood the problem. Okay, so this is one example problem given to you to solve. You can work out this problem in your class note and we can see the answer in the regular class. Okay, so the four training corpuses given to you. These are the four training corpuses. This is the test corpus. I love coding in Python. Okay, so for this you calculate the probability and check the answer. Okay, thank you.